So let's look at graphing these rational functions. So number 10, we have f of x equals 6 over x plus 4. Now, the domain is based on the x values, and the x values are connected to the vertical asymptote. So we're going to find the vertical asymptote by setting the denominator equal to 0. Subtract 4, x equals negative 4. So that tells me I'm going to have an asymptote at x equals negative 4. So 1, 2, 3, 4. So there's my asymptote. Now, the y has not been translated at all. This is plus 0 here. So my horizontal asymptote will remain at 0. This is the parent function asymptote for rational functions. Y equals 1 over x plus 0 is the standard parent function. So we can go back and fill in this table here. The domain is going to be any value except where the asymptote is located. So x cannot equal negative 4, and the vertical asymptote occurs at x equals negative 4. The range is going to be everywhere but where the horizontal asymptote occurs, and this is at 0. So y cannot equal 0 for the range, and the horizontal asymptote will be located at that value, y equals 0, because there's no translation here. Now the graph, we'll just fill it in. The parent function, as a quick reminder, looks something like this. So as you can see, the horizontal asymptote is at y equals 0, the vertical asymptote is at x equals 0. We can see it's been a little translated here. This one's been moved to the left 4, but the y has not changed, it's still at 0. So I'll leave that there. Now we can just fill in some points. So when x is, let's choose negative 3. So when x is negative 3, that's going to be 1, 6 over 1. So at negative 3, positive 6. 1, 2, 3, 4, 5, 6. So there's a point there. If I put in a negative 2 for x, that's going to leave a 2 here. 6 over 2 is 3. So negative 2, 1, 2, 3. And then if I put in a negative 1 plus 4 is 3. 6 over 3 is 2. So negative 1, 2. You can get one more point here at, let's choose positive 2, because that'll give us 6 here. So positive 2, this equals 6. 6 over 6 is 1. So positive 2, 1. So you can see the shape of the graph here. And then we can do the mirrored points here. So this is going to be up, down 6. 1, 2, 3, 4, 5, 6. This one will be 2 more up 3, or down 3, I'm sorry. And then 1 more over 2. So we can see the mirrored points on the other side. This can also be found by going to the table if you'd like to see a table of values, or by further plugging in like we did here. So here's our graph.